we can work with derivative of inverse functions. So inverse function are the inverse function of trigonometric function. So we have arc sine of x. In some book you see this is sine inverse of x, but remember that this is different from 1 over sine of x. So this is an inverse function, the inverse function of sine of x. This is reciprocal of sine of x, so this is not the same thing as the inverse function. So that's why I would prefer to use this notation, arc sine of x. And we also have arc cosine of x, arc tangent of x, arc cotangent of x, arc secant of x, and arc cosecant of x. Now we want to learn what is the derivative of those. Compute the derivative of those inverse function. So here's on methods you can remember that. Let us look at the left hand side first. The right hand side I will work with them later. We will have fractions. And now for arc sine and arc secant, I see the s here. So we think of that as subtraction. S stands for subtraction and square root. So we will have that for arc sine and arc secant, subtraction and square root. Now, for tangent, I see t, so it looks like the plus sign, so I have the plus, no square root at all, just plus there. For the first term, we will have 1 minus x squared. For the second term, 1 plus x squared. For the last term is a bit different with secant, so I will have absolute value of x squared 1. Hopefully you can remember that. And on top, it will be just 1. 1, 1, 1. So these are the formula for the left hand side. For the right hand side, I will just copy that formula and I put the minus sign there. So let's copy the formula. And put the negative sign. Minus, minus, minus. Yeah, so that's going to be our formula. If you want to use the chain rule, instead of x, you have function u in terms of x. So here's how it goes. So when you see x, here you have function u. And then because we have a chain rule, right? So it would be u prime on top. So arc sine u, arc tangent u, arc secant u. Down there you have u square, u square, u square minus 1. And then here I have absolute value of u. And same for the right hand side. We just put the negative sign in front. Negative. So these are all formulas. Now let's try to show some formula. Let's try to show these formulas. So now let me compute the derivative of arc sine of x. Let me denote y equal to arc sine of x. So the inverse sine of x. Here's the unit circle. the vertical lines here, this one corresponds to the y-axis, so from -1 to 1, right? So our sine is an angle, so that sine of that angle equal to x, sine of y equal to x, because these two functions are inverse of each other, are the inverse function of each other. Y equal to x, sine of x, so this means that by convention, the angle y here will take the values from minus pi divided by 2 to pi divided by 2. It will cover all the side from -1 to 1 unit. So the angles run between minus pi over 2. So this angle, for example here, the angle will be minus something pi over 4. Minus pi over 2 can run until plus pi over 2. So we call that y is from minus pi over 2 to plus pi over 2. Now x equal to sine of y, you can do derivative both sides. Differentiate both sides of this equation, you have sine of y prime equal to x prime. So sine of y prime is y prime times cosine of y. I use the chain rule. X prime equal to 1. So this means that y prime equal to 1 over cosine of y. Cosine of y different from 0. Y is not minus pi over 2 pi over 2. This means that x equal to sine of y. X is not in sine of minus pi over 2 sine of pi over 2, which means x is different from -1 and +1. So we only want x between -1 and 1, and we don't include the points of the boundary of the interval. X between -1 to +1. Okay, just a note there. Now you have y prime equal to cosine of y. Cosine of y, we have this formula. Sine square of y plus cosine square of y equal to 1. So you can write cosine in terms of sine. Cosine square of y, 1 minus sine square of y. I can square root both sides. Cosine of y, I put the absolute value because I do square root, equal to, because this one is always sine of y is from -1 to 1. So this one sine of y square always less than 1. So this one is always positive. I can do that square root. 1 minus sine square of y. Now look at this. Cosine of y can be plus or minus this square root. However, the angle we are working with between minus pi divided by 2 to pi divided by 2. Cosine of that angles here take the values bigger than 0. That's why we have cosine of y equal to square root 1 minus sine square of y. We don't want to have the negative values for cosine of y. So now I can write cosine of y is 1 minus sine square. 1 minus sine square of y is 1 minus x square. This one is square root 1 minus x square, because x equal to sine of y. Now y prime equal to 1 over cosine of y equal to 1 over square root 1 minus x square, and here we want x between -1 plus 1. So y is a function arc sine of x. So that's the derivative we need to compute. Arc sine x prime 1 over square root 1 minus x squared. So you see now why the derivative of arc sine of x is 1 over square root 1 minus x squared. Sine square root subtraction. So remember that. Now let's do another example for arc cosine of x prime. You do similarly. So let y equal to arc cosine of x. Y equal to arc cosine of x. Here's a unit circle. The horizontal lines correspond to cosine axis. You have cosine axis, so here we want cosine. We know that cosine of an angle between -1 and 1. Y equal to arc cosine, so the angle y is an angle, so that's cosine of y is equal to x. Cosine y is equal to x. Arc cosine and cosine are inverse of each other. So that angle, we need that one by convention. We will use the angle between 0 and pi, and it will cover on the cosine axis here. The angle between 0 and pi. Y, arc cosine of x, that one will be an angle between 0 and pi by convention. Make cosine of y is between -1 and 1. Now you do derivative both sides. Cosine y prime equal to x prime. You use the chain rule for the left hand side. Y prime minus sine of y equal to 1. Here you see that sine of y must be non-zero, because otherwise the left hand side will be 0, the right hand side is 1, 0 equal to 1, which is abscess. Note that sine of y must be non-zero, which means y must be different from 0 and pi. Y not in the set of 0 and pi, which means that x cosine of that x must be between -1 and 1. We don't count the endpoint of the interval x between -1 and 1. So just note that when you compute the derivative. Now, because sine of y is non-zero, you can divide it both sides by sine of y. I divide it by minus sine of y. So y prime -1 over sine of y. Now we need to write down all here in terms of x. So let's do it. Sine square of y plus cosine square of y equal to 1. Sine square of y 1 minus cosine square of y. We know that cosine of y between -1 and 1, so this term's always positive. You can do square root both sides. The left hand side becomes absolute value of sine of y. Right hand side square root 1 minus cosine square of y. Now let's try to remove these absolute values. You see that we are working with the angle between 0 and pi, and actually we didn't even count 0 and pi in this case. So sine of y is this vertical line. This one is for the axis for sine of y, which is always positive in this case. Right? Therefore, you can remove the absolute value. Sine of y equal to square root 1 minus cosine square of y. So sine of y is 1 minus cosine of y equal to x. So this is 1 minus x squared. Square root 1 minus x squared. Now we put it here. Y prime minus 1 over sine of y minus 1 over square root 1 minus x squared Yeah, so we get it done. Y is a function as cosine of x. Let me compute the last one. Example. Compute arctangent of x prime. Y equals arctangent of x. This means that x equal to tangent of y. They are inverse of each other. So now let's do the derivative. X prime equal to 1. Tangent y prime tangent y prime of y. So I use the chain rule there. So now tangent prime secant tangent prime is secant square. Tangent prime of y is secant square of y. So left hand side you have 1, x prime equal to 1. Right hand side you have y prime times secant square of y. Secant of y is 1 over cosine of y. This one is always non-zero. We can safely divide both sides, or I do y prime 1 over this. 1 over secant square of y. A formula to remember. Secant square of y equal to 1 plus tangent square of y. You don't need to memorize this formula. We can deduce that from definition. So secant of y is 1 over cosine of y. Secant square of y is 1 over cosine square of y. 1 is sine square of y plus cosine square of y over cosine square of y. This one you have sine square of y over cosine square of y. Cosine square of y over cosine square of y, so plus 1. This term is sine over cosine square, so this is tangent square of y plus 1. That is why you have this formula. So it's here. Now let's plug in here. You know that 1 over 1 plus tangent square of y. Now you can write in terms of x. Tangent of y is x, so this is 1 over 1 plus x squared. So that's why you have the formulas. Arctangent of x, y is arctangent of x prime 1 over 1 plus x squared. So for tangent, you remember this as a plus.